This is Frank, and I've been playing around a little bit. I want to share some of my toys with you. So, what I want to do is, I was just drawing a square. See this big square? And it could be any square you want. Notice there's the four right angles. And the sides, I tried to make them congruent. And then what I did is I put a dot. Let's look at the top side. Anywhere you want. Anywhere you want on that top side. Just arbitrarily put a dot. You can put it here, here, in the middle, over there. I just put it there so you could see it visibly. So you've broken the side up into two pieces. So we're going to call this side X and this side Y. But then what I did is I subdivided the other sides the same way, but I staggered it. I made this length the same length as X. And this length, the rest of it, your Y again. And I continue this. I made this side your X. And the rest of it, your Y. And finally, this side. I made this side was your Y, and this side's your X. So it's X, Y, X, Y, X, Y, X, Y, right around. Okay, so I subdivided. Then I was thinking about forming triangles, right triangles. So what we would do is we would connect these 2 points into a right triangle. And these 2 points into a right triangle. Likewise, these 2. And finally, these 2. Now, what I decided to do is, I don't know what this side is, but we'll call it Z. And we know from triangle congruences, you got a side angle side, you got a side angle side, a side angle side, a side angle side. So those triangles have to be congruent. So that means those longer sides are all Z. Then what I did is I looked at the slopes of some of them lines. Now let's look at this line. The slope is the rise over the run. So the slope of this line would be Y over X. Let's just write that down. That's this line. So let's take the slope of this line. Well, the slope of this line would be your rise over your run, but that would be negative X over Y. Negative X over Y. Now, so what do we notice? The slopes are negative reciprocals of each other. And we learned that if the slopes are negative reciprocals of each other, those lines are perpendicular, which means they form a right angle. So it means all four of these are right angles. So what have I drawn inside is a square inside. This is a square. The sides are all the same. The angles are all 90. So I was wondering if I could find the area of that big square. So what is the area of a square? It's the side to the second power. So if this is x and this is y, then that whole side is x plus y. That's the whole segment. And likewise, all four sides are x plus y. So how do you find the area of a square? You square the side. So the area of the square, this is the area of the big square, is x plus y squared. Okay. Now, let's add up the pieces inside. What do we have inside? That big square is made up of one little square, and the area of this square is z times z. Plus 4 triangles. But each of these triangles have an area of 1/2 base times height. 1/2 base times height. 1/2 base times height, 1/2 base times height. So there's 4 triangles, and each area is 1/2 x times y. So let's look at this. Let's expand this binomial. Let's combine this. 4 times 1/2 is 2, and you have 2xy. Okay, let's double distribute. Some call it FOIL. What have you? X times x, x squared. X times y, xy. Y times x, we're just going to call it xy again. And y times y, y squared. Now that's the area of the big square, and the area of the innermost square and the 4 triangles is this. Well, we add xy and xy, we get 2xy. And notice they both have xy, 2xy, so we subtract it. We got x squared plus y squared is equal to z squared. And if we look at any one of our right triangles, that's playing time. Pythagorean theorem. We just played around and came up with the Pythagorean theorem. I'd like for you to try it. Have fun, play hard.